guys. Welcome back to Eggs. This week we have a special guest, Andrew Murphy. Andrew is an award-winning product development, innovation, and business transformation executive and industry expert in the field of hydrogen energy. As a noted board advisor and APEA Award winner, Andrew has led the creation and development of groundbreaking hydrogen and innovation initiatives in multi-billion-dollar organizations. With a background in renewables and water, Andrew sees the Food-Water-Energy Nexus as the great challenge of the 21st century. Joining us today to talk about the role of hydrogen in the future, innovation happening now in the industry, and so much more, please join us in welcoming to the show Andrew Murphy.
Hey, Andrew, welcome to the show. We're so glad to have you here, man. Hey, I wonder if you wouldn't just kind of begin this conversation by giving us a little bit of background information on who you are and what you do. I mean, obviously, you know, we're having you on as an expert in hydrogen and things like that. But I mean, the laundry list of accolades and everything else you see on LinkedIn and all these places is incredible. So I wonder if you could just give us kind of a little, elevator pitch version of who you are and why we're talking today.
Well, thanks for having me on, guys. It's a real pleasure to be here. I've been involved in hydrogen for about a decade now, which in the context of hydrogen and the energy transition kind of makes me an old hand. So I joined the Shell hydrogen team back in the UK about 10 years ago, when it was essentially a startup in an otherwise very big company. And that was really an interesting entry into the field. Hydrogen previously had been through several kind of hype cycles and never quite got over the hump, so to speak. And this one was, a lot of people in the industry thought this was the last chance. So in that job, I was a hydrogen technology engineer. I worked with the likes of BMW, Air Liquide, Linde, all the players who really had an interest in hydrogen to drive down the cost of the equipment that is needed to get it to the public cheaply. Involved with a lot of European funded projects over here, so funded by the European Commission, collaborative projects of various countries. Worked on guidance documents to mean that it's actually legal to put hydrogen on a refueling station, so you can have it next to your petrol or diesel dispenser. Fair amount of strategy. Worked alongside Shell Ventures to look at investments in various hydrogen companies there. So the full gamut really of some business development strategy, technology development, commercialization, and that was really great. More recently, a couple of years ago, I set up my own consultancy, RHC Imzadi, which is essentially a hydrogen and energy storage consultancy. And the timing has been fantastic because over the last couple of years, we've seen so many countries setting up hydrogen strategies and white papers. The European Union has individual states within Europe, Australia, Canada, all coming out saying we want to put a lot of money into hydrogen. And over the last 12 months, with talk of green recovery, more and more attention has been paid to hydrogen there. So that's been really good for my business. I've been involved with some very large hydrogen mega projects. Can't name them because of NDAs, but a number of very large projects are coming online now for green hydrogen. So we're talking hundreds of tons a day. Look at Australia, some of these places, looking to export to Japan. And I've been working alongside a bunch of small startups who are trying to break into the hydrogen arena, basically trying to help them get some funding from venture capitalists and interested larger companies who want to move forward in the energy transition and have deeper pockets than these small companies.
Well, that's a very extensive career you've had, and I like that you've gone into the consulting world. I honestly, and from the research that I've done over the last 6 months, I honestly feel that hydrogen is going to be the solution to a lot of the problems that we have in our renewable energy source. Can you, we kind of did a brief overview of this before we started recording, but can you talk about the difference between a hydrogen combustion engine and a hydrogen fuel cell and how it works? I know that, there was there's been videos of the guys that, create a combustion engine out of their old truck and burn hydrogen and say, oh, we're making, there's no downside to doing this, and we're running off of water, and it just puts water out in the back. But I've also heard that by doing a combustion engine, it emits nitrous oxide. Is that correct? And what are the downsides of doing the combustion versus a fuel cell system?
Well, there's upsides and downsides to both, which is interesting. So internal combustion engines have been around for 100 and something years. They're very well understood, and they're relatively cheap. So you can convert your standard diesel engine to run on hydrogen, and you can run it on hydrogen, which isn't particularly clean. The downside there is it's not the most efficient way to use your fuel. So the amount of energy you have in your hydrogen, you may be getting say 30-40% max coming out of your crankshaft in your car. However, doing a conversion is relatively cheap, and there are some really interesting companies out there, like the likes of Ulemco, who are converting diesel vehicles to be dual fuel, so run on hydrogen and on diesel, which is really nice. So if you already have an existing fleet and it's only a couple of years old and you don't really want to replace anything and invest in new technology, then going down that route is fine. It also means that when you don't have the ability to refuel on hydrogen, you can carry on using diesel. In terms of hydrogen fuel cells, that's a different technology. It's a lot newer. Hydrogen fuel cells, I think, were used in the Apollo mission, but they were very primitive to what you get today. But now you can get a 100 kilowatt fuel cell in your vehicle, in your Toyota Mirai, and essentially it takes air on one side, passes the air on one side of the fuel cell. You have a tank of high pressure hydrogen in the back, so that's 700 bar, so about 700 atmospheres pressure in carbon fiber tanks. Passed through a valve, and essentially there's a chemical reaction across the fuel cell, oxygen on one side, hydrogen on the other. Hydrogen passes across, generates water, and meanwhile there's electricity generated in a current, and that electricity is tapped off. And once your electricity is tapped off, everything else there is essentially the same as your battery electric vehicle. So hydrogen fuel cell vehicles are electric vehicles. It's just that the energy is not stored in a battery. It's stored in a chemical fuel, which is hydrogen, and it's released by being passed through a fuel cell.
So is there any downside to having a pressurized carbon fiber tank to store your hydrogen on your car? Is there is it like a what's it called? A gremlin? If you get hit in the back, it just explodes?
Really interesting videos out there done, I think it was by Volkswagen or BMW maybe 15 years ago, where they had two identical vehicles, one with a gasoline tank and one with a hydrogen tank, and pierced them. I think it was with a forklift truck, but other people have done it with bullets and things. And in the space of about 30 seconds, because hydrogen is so light, it comes out, goes straight up and burns, and then it's gone. With your gasoline, it comes out, pools around your car, combusts, and spends the next 5 minutes incinerating your vehicle. So if I was trapped inside a hydrogen fuel cell vehicle, which had a punctured tank, versus a similar car with gasoline in there, I'd much rather choose the hydrogen tank. And people say, well, hydrogen is explosive. So is most liquid fuel, right? Don't smoke at a normal refueling station. Don't smoke at a hydrogen station. And I've worked on developing hydrogen refuelers, and I can say without a doubt that is safer. You go to fill up your normal car, you can smell fumes, right? That's all stuff that can burn. Hydrogen refueling, there's just really minimal risk. And probably at some point in the future there'll be some accidents, but I'd guarantee really that the amount of accidents and the severity are going to be below what you get from your normal refueling.
Well, yeah, I think that's a good point to bring up, though, that there's just there's no free lunch, right? I mean, if you want combustion, you're going to have some sort of chemical reaction. And it makes a lot of sense that, okay, if gasoline and hydrogen will both explode, but one explodes less, like, okay, that's still an improvement, even if it still explodes. So I think it's good to kind of point that out. I wonder if you wouldn't talk a little bit about sort of we're talking a little bit about future technologies and things like that, but I wonder if you wouldn't just sort of talk about hydrogen. We talked briefly before the show about hydrogen has actually been around a lot longer than we think it has. I think, people who haven't done extensive research or haven't, gone down the YouTube rabbit holes have, maybe a cursory relationship with hydrogen. And I wonder if you'd just sort of talk about it as a evolving technology.
Well, and I think Honda has been working on hydrogen automobiles since the early 80s. So it's not even just, the crazy guy that, understands a lot and does it in his garage. Commercial applications have been working on it for a long time. So
if you look at kind of GM and Ford as well, and most of these other companies, they've all done some work on hydrogen vehicles. BMW back late 90s, early 2000s, looked at hydrogen vehicles fueled by liquid hydrogen, which is interesting. That didn't go anywhere. But it's all the improvements we're seeing these days are based off kind of learnings of the past. We couldn't have got to where we are without that in the past. And as I kind of mentioned before the show, there's about 70 million tons of hydrogen produced worldwide every year, but you don't generally see it. Most of it's produced next door to a refinery or produced next door to a fertilizer plant. It goes across the fence and is immediately going into your fuel or your chemicals or your fertilizer. Now, the issue with that is most of it's coming from natural gas or gasification of really nasty residues from our refinery. So nobody makes really a big deal about it. It stays in the pipe and it gets processed. The hydrogen is fine. You can use it for all these kind of say energy transition applications like fuel cell vehicles or internal combustion engine vehicles. It needs purifying a bit, but at the end of the day, the fact it's coming from a fossil fuel to begin with means that there's CO2 coming out somewhere. So the real big transition for hydrogen that we're seeing now is, although there's 70 million tons of a year being produced, is that we need to replace some of that with greener hydrogen. We need to have applications which, when they come online, are using green hydrogen rather than kind of high CO2 hydrogen to begin with.
So,
and I think, sorry, Mike, go ahead.
I was going to say, so the difference between like a green hydrogen versus just a byproduct of what the refineries are doing now is the refining process. There's a lot of different tech out there to actually make hydrogen, and there's steam-based electrolysis and different options. And I think you mentioned earlier that the ability to like have excess, like power from like the solar abilities and the wind generation, it's allowing us to do electrolysis to create the hydrogen without really having any downside because we're using renewable resources to create it in the first place. Is that correct?
That's right. I mean, historically, if you look at the prices for renewables, they've been quite high. And also the cost of your electrolyzers to produce hydrogen. So electrolyzers split water, kick out oxygen, which you can use or throw away, and then you keep the hydrogen. But they've been expensive. The cost has really come down, and there's some great cost projections there as well. But the cost of the power now from renewables is just so competitive with everything. I look at kind of solar bids in Portugal last year, where the bid was 1.3 cents per kilowatt hour. So almost free. And they're putting in so many solar arrays and wind turbines in places. We have times when there's electricity with negative value. So we can get the cost of the electricity down, and we can get the cost of the electrolyzers down. Then you don't even have to run your electrolyzers 100% of the time. And their efficiency has gone up so much that when you do run them, you can start to get to the position where you're using green electricity to produce green hydrogen close to the cost of your fossil hydrogen, and in the future probably hopefully less than the cost of your fossil hydrogen.
Yeah. So if I'm understanding this correctly, I mean, is that sort of what you would attribute, I guess, sort of this up and to the right chart of hydrogen use and things like that is, even though it's, not necessarily the newest technology, I think you mentioned that they were using some version of a hydrogen cell on the Apollo missions. But, the efficiency with which we can make the conversions now and the way that we can actually apply this stuff now, is that I guess why it's starting to I guess sort of start to shine now is we're starting to see more and more hydrogen use because technology's finally caught up to it?
Some of it is politics. Some of it just happens to be the right place at the right time, and a lot of it is the technology. So if you look at Apollo, I don't know how much the hydrogen fuel cell for that cost, but it'll be in the millions, probably tens of millions by today. Big, primitive, probably reliable because it went used in space. But these days it have to be produced in the tens of thousands, be a lot smaller and be much more efficient. And all the components that are going in there's a lot of really good engineering expertise for modeling the flow of the gases and these other things. It's let everything become much more reliable, a lot smaller. And when it's smaller, you need less materials, and less materials mean easier to produce cheaply. So we're kind of into a virtuous cycle now. Because it's cheaper, people will buy more of them. That means there's more use. That means there's more room for cost down. And when it's cheaper, again, people will buy more of them.
Well, and is there more room to grow on this technological front? Like, I mean, are we going to continue to refine, and this will be the process that we start to, I guess maybe eventually eclipse our reliance on fossil fuels?
I mean, absolutely. I mean, I'm in a lot of conversations with different suppliers and technology developers, and I never fail to be kind of amazed at some of these developments that are going on there. And I realize people are very optimistic, so even tasting it with taking a pinch of salt. I've seen some very real projections from some very good companies for the cost of producing these fuel cells. And we're talking not 25, 50, 75% reductions on today's price, even more. And today's price is a lot cheaper than it was 5, 6, 7 years ago. And when it gets to that level, then suddenly your powertrain for your vehicle from your fuel cell is actually way cheaper than it would be for a diesel powertrain. So why would you choose diesel when you can have a fuel cell? And the answer for that is you want your hydrogen to be not too expensive when you sell it. And that's where the other part of the equation we discussed comes in. So you can get your green hydrogen. It's cheap because cheap electrolysis, cheap renewables to power that. So we're in a virtuous cycle now. There's still some work to do, but it's a very positive position to be in.
Well, so they already have fleets of taxis and city buses and all sorts of different vehicles that are running on hydrogen. And the cost of producing the hydrogen right now is fairly expensive. So it's cost per gallon of gas, for example, is cheaper than a gallon of or liter of hydrogen. So by having the tech become more prevalent, more people producing it, I assume that's going to go down. A lot of the problems as far as like creating and storing hydrogen comes in like there's no systems in place right now for gas stations to be able to store it, the transporting of the hydrogen to get to the gas station. I've heard a lot of the gas stations that have the hydrogen capability right now are producing it on site.
That's right.
Is that going to be kind of the model? Are most of the places that are going to be able to provide hydrogen solutions for consumers, are they going to essentially just have to create their own process of making it and storing it on site?
That's actually a brilliant question. So currently there are 3 different types of hydrogen stations for vehicles. And they're basically broken down into some stations where it's delivered by a pipeline. They've built a station near a hydrogen pipeline that happens to be nearby. They've tapped it off, purify the hydrogen. That's the kind of best case scenario because somebody's already paid for the infrastructure. There's other ones where it's delivered as compressed gas. I led a modeling effort a while ago to look at the economics of that. So for the first 150 miles, maybe, it's kind of economic to deliver it by truck and have it, shipped in. But beyond that, then electrolysis tends to be the cheapest way to, produce it on site, really. And with the cost of on-site production coming down, then the window of attractiveness for delivered hydrogen starts to shrink. So there's always going to be some hydrogen delivered, but it looks more and more likely that a lot of it will be produced on site via electrolysis. And in some cases, you can produce it on site through natural gas reforming as well. So there's a couple of options there.
So
what do you think?
Oh, go ahead, Ryan.
Go ahead. I was just going to say, so what do you think? I mean, how do we make this attractive to the big fuel companies, for example? I mean, not to ask you to give any like inside dirt on Shell's thinking or anything, but like, if I'm, running a chain of gas stations or, something like that, when will I know, or are there things we can do to expedite the demand for this product? I mean, obviously, if it's physically capable to produce on site, that's one hurdle. But the other hurdle is if I'm going to invest in all that infrastructure, how do I make sure I've got enough of a crowd to buy it? So what do you think that transition looks like?
His father actually owns a truck stop. So he's wanting some inside information for his dad.
I can probably recommend after this some providers of equipment if your dad's interested.
Excellent.
But so it comes down to cost, right? Nobody wants to spend a huge amount of money putting this infrastructure in the ground, and nearly every hydrogen refueling site now, there's some level of funding through either through kind of say California government or the German government or UK funding in various countries. None of these sites are paying for themselves. And the reason they're not paying for themselves is they were expensive to put in. These days, they're becoming more and more similar. So the cost is coming down, which is great, but it comes down to demand. So if you have a station that's only dispensing 5% of the amount of hydrogen it could per day, you're never going to pay for it. If you've got a station that's 95% utilization, you start to make some money on that. So it does come down to utilization. It comes down to knowing where the vehicles are going to go in and knowing which vehicles are going to use a lot of fuel. So your normal car, you got your Camry or something. If they decide to go over to hydrogen, fuel cells on that, or you have a Toyota Mirai, still not going to use much fuel unless it's being used as a taxi. But if you're doing haulage, you've got a Class 8 truck, and these are blasting up and down the freeway continuously, they will burn a lot of fuel. And that can be diesel, or it can be hydrogen, or it can be something else. And they'll need to refuel. So the best idea is to put these hydrogen refueling stations where there will be high demand. And that means working with these truck companies to say, look, if you go over to hydrogen, we may even put a refueling station at your depot where your trucks go overnight, so you don't have to worry about that. But show us what your main routes are. We're going on this highway. Where do you normally want to refuel? And we will put in refueling stations along there. And then suddenly you start to develop hubs, and kind of a hub and spoke model. And it encourages other companies who maybe only have a couple of trucks to get involved because they know they can refuel too. That increases your profitability. You can put in more stations. More stations means the cost of stations gets cheaper. So that's really how I see the kind of profitability coming up and the cost going down.
Yeah, I think that makes a lot of sense, because I mean, it's kind of this chicken and the egg thing, right? You don't want to just build stations when there's no demand, but we need the chickens to start running on hydrogen, and so that they can, so they need it.
Ryan,
so it makes sense to do it in private ventures like that.
Ryan, if you think like 10, 15 years ago, there weren't charging stations for your Tesla at every super mall or gas stations or, along the major corridors. But now if you drive, from Idaho to Washington, there's, fuel charging stations all along that route because the demand is there. So it's worth the investment. And I honestly see the same thing happening with hydrogen in the next 10 years. The same kind of, the cars are going to start showing up and they're going to be out there and there's going to be a demand for it. And then at that point is when you're going to start seeing them pop up. As far as, like a fuel cell vehicle, Tesla's out there right now. And if you look at a Tesla, their battery pack is literally the entire bottom of their car. It's huge. And they're doing that so they can get more range out of the vehicle. But with a hydrogen fuel cell setup, the battery can be a lot smaller because it doesn't necessarily need that size for the range. So by having that as a workaround, you can actually get a lot further without having to stop, charge, and go. And it's also takes up less space in the vehicle, and it's not as heavy, because the lithium ion batteries that Tesla's using right now they're super heavy, and it requires, bigger brake pads, bigger motor to power it, all sorts of different things that come into play by having that larger battery. And by having the hydrogen option in a smaller battery, it creates a smaller footprint, and you can do more with it. So I'm really excited to see how that works. Am I on the right? Did I describe that right, Andrew?
Yeah, very, very well, actually. That becomes really important when you look at things like trucking, because beyond a certain point, you don't want to keep adding batteries to get distance, because your batteries have so much weight, then you're just paying to haul battery, right? With hydrogen, you can just add a few extra kilograms of hydrogen. So that doesn't take up much extra weight, and the further you drive, the more fuel you use, the weight goes down. So for heavy vehicles and for vehicles going a long way, then hydrogen is very attractive. I've seen things out there like hydrogen scooters for around the town. There's no point for that. You can charge up, from your wall socket at home and use a small battery. But if you're trying to go a long way, if you're trying to haul a lot of weight, then hydrogen becomes very attractive. And no matter how fast you can recharge with a Tesla supercharger, I think that's like 100 kilowatts, 140 kilowatt charging. You were talking the equivalent charging rate for hydrogen is in the megawatt range. You can refuel a car in 4 or 5 minutes. You can refuel a lorry or a bus in under 15. Whereas if you had 17 tons of batteries in a Class 8 truck, you are not going to recharge those in 15 minutes, and they're going to get very hot while you're doing that.
So the whole reason I went down this hydrogen path of trying to learn more about it is I saw this video of a guy that a little inventor over on the East Coast that created this lawnmower that was solar powered and hydrogen. It was a bed lawnmower that he converted with hydrogen and then solar as well. And instead of having like an hour and a half runtime with this riding lawnmower, he can get a full day's use out of it by converting it to hydrogen. And I'm kind of going down this route of wanting to do landscaping and lawn care. And I don't want to go and buy a combustion engine for, an expensive lawnmower commercial engine and spend like 10, 15 grand on. If there's an alternative out there, which it looks like there is. So I'm kind of really excited about it. And that's what put me down this wormhole. And what was I going to say? Oh, Toyota is developing a solid state battery right now. And they're getting to the point where they can almost produce it on a commercial level. And it has a higher energy density, low risk of fire, faster charging. You can get up to 500 miles with it, a 10-minute charge time. How do you see the solid state batteries working in conjunction with hydrogen in the future? Do you think that's going to be a thing?
I hope they're successful. We need every piece of technology as cheaply as possible for the energy transition. So if something comes along that happens to be better than hydrogen, I'll absolutely jump on board that. Batteries are always going to have some limitations. So a battery may be able to be charged quickly, but kind of the behind the wall piece, your transformers, etc., needs to be able to cope with that. Even with chargers these days, you're looking at liquid cooled chargers and having substations nearby to cope for that. Whereas with hydrogen, you can produce it, if you produce it centrally at least, you don't have to have all that investment in your back end, so to speak. But these solid state batteries are interesting. So if we look at some of the vehicles which are going to be developed now, already developed with hydrogen fuel cells, is very often a hydrogen fuel cell and battery combination anyway. So you will either have hydrogen as a range extender, so enough batteries to do, say, 40 kilometers or something, and then the rest of your range on hydrogen, or even just smaller battery for your regenerative braking. So anything that can make the batteries more efficient, I'm absolutely in favor of. And I do think that overall, we will see a lot of benefits of hydrogen and batteries being integrated together in the energy system.
So we've talked a lot about, personal vehicles and semi-trucks. What are some other applications that we haven't discussed? The shipping is a huge one. You brought that up a little bit as far as the big shipping containers are running off of diesel. It's very bad for the environment. I've seen some schematics of a tanker that's set up with a fuel cell solution that looks very interesting. And I don't know if they've already got them in place or not, or if it's still tech they're working on. But you got the shipping industry. What about homes? Providing electricity for your home or commercial products?
That's an interesting one. So hydrogen for buildings is still a little bit further off in my opinion. So I think there's going to be definite applications in marine in certain areas, especially areas where you were limited by the amount of kind of pollution you're allowed. I think I mentioned trains before. Definitely applications in trains in areas which are hard to electrify, so substitution of diesel, and hydrogen gen sets. So if you look at building sites, they have these diesel generator sets kicking out smog. It's not pleasant, it's inefficient, it's loud. With cheap fuel cells, you can just replace that with hydrogen, and that is a huge improvement. I know there's a lot of kind of businesses looking at that area now. For homes, yes, hydrogen potentially for combined heat and power. So you could have a small fuel cell in your house, and you use that to generate heat and power. There are already fuel cells for homes that run off natural gas. So it's not too far of a stretch to look at hydrogen fuel cells for homes. But the issue is then, how are you getting your hydrogen to your house? So you want it to come through your natural gas network. In the UK, there is a really interesting project at Keele University where they have a separate natural gas grid than the surrounding area. So they converted that to run hydrogen and use that to be used in the campus buildings, which is interesting. And over here, we're also looking at doing, first of all, kind of a hydrogen village, then a hydrogen town by 2030.
I know that Japan is actually working really hard to get their whole infrastructure set up on hydrogen as well.
Yeah. So they wanted to do the Hydrogen Olympics in 2020, and there's a huge amount of investment gone on there behind the scenes. And then essentially they wanted to kind of show the world of, look, Japan is the leader in hydrogen, and in many ways they absolutely are. So it's been a real shame we weren't able to have that Olympics, and these companies that have been involved in that technology to advertise it by the Olympics. But I'm hoping that in 2021 the Olympics do happen, and we do see a lot of the potential in Japan of hydrogen. So they're really looking across the whole chain. So hydrogen in buildings, in mobility, for energy storage. It's really all there.
I wondered. Oh, go ahead, Mike.
Oh, sorry. Does temperature play a factor in the storage and use of hydrogen? I recently went up to Nome, Alaska to do some work, and it gets really cold there in the winter. And their only source of heat, or the major source of heat, is burning diesel. That's how they heat their homes. And the way I'm thinking is, if a hydrogen solution out there, a community like Nome could drop the diesel heaters and be able to power their homes and heat their homes with hydrogen. But if it's negative 30 degrees out there, is that a problem with a hydrogen solution?
I mean, the hydrogen gas itself won't notice. Until it's minus 200 and something, it doesn't turn to liquid, and then you can still use it. You probably want a little warm up for your hydrogen fuel cell, but the hydrogen fuel cells generate heat anyway. So if you have a hydrogen system over there, the temperature of your hydrogen doesn't make any difference. Your fuel cell will be kicking out enough excess heat that you can use that for warming your buildings as well as producing power. And it's not like diesel; it won't turn to slush and cause a problem, and it won't separate out. It's not where if you get diesel's a combination of different molecules, you can get separation and things. So no, heat's not really an issue. And in fact, hydrogen has some advantages. So again, if you look at vehicles, if you're driving up in Alaska in your Tesla, which obviously, I like Teslas, great cars, but you want to heat your car, you switch on your heater and your battery really quickly. because you're using electricity, but your fuel cell, because it's not 100% efficient, does kick out some heat anyway. So you can then use that heat to heat your vehicle. So you're not having to use extra hydrogen to generate that heat. Now, if you live in totally temperate climate, you don't get that benefit. But if you live in Norway or Alaska or Canada, then there are real advantages to that.
Ryan, were you going to say something?
Yeah, I just wanted to ask. So we've spent a lot of time talking about transportation and things like that, but I wonder if we could talk a little bit about other emerging markets. I think you mentioned in our little pre-show discussion the use of hydrogen in agriculture. And I wonder if you'd maybe talk about that. And I wonder if there's maybe some increased demand in those spaces. I don't know if it's related or not, but I've seen a lot of recent like fertilizer companies and things like this that are trying to get into really hyper clean, hyper green kinds of fertilizer solutions and things like that for, largely to support the cannabis industry here in the States, but, also just to sort of, transition those products into more sustainable and greener goods. I wonder if you could talk about the role of hydrogen in those types of markets.
That's interesting. Well, that's an emerging market. So for years, people have talked about shipping hydrogen around in large scale and generally talks about doing liquid hydrogen. But a lot of attention has now moved to shipping ammonia. So producing hydrogen, converting it to ammonia, and then shipping that around. Then you can either extract the hydrogen or you can use the ammonia either as a fuel itself or in other industry. So ammonia is usually most produced chemical worldwide, we'll say. Most of it going into fertilizer. So suddenly we have this situation where we're producing a lot of green hydrogen, ideally very cheaply. The ammonia industry can look at this and say, wait, if we use this green hydrogen, we don't really have to change the rest of our process. And yes, there are ways to do that, but you can stick with the same process, but our ammonia is greener. And then the fertilizer industry, which we sell that into, which has a very bad reputation for emissions, it helps them offset some of their emissions by using green ammonia. So it's part of the value chain. If you green your hydrogen, you green your input into ammonia, you green your fertilizer. So, I mean, you mentioned the cannabis industry. I think I read an article about some producers there saying that they're using, just renewable electricity for the lighting and things. Well, if you look at from the other end, if they're using renewable electricity to produce the hydrogen, to produce the fertilizer, then your emissions overall start to come down to zero. And in some sectors of the community, people are very attracted to, these environmentally conscious businesses.
Yeah. Well, and I think, I don't think it's a coincidence, but I've seen several sort of like IPOs and things like that recently for these companies that are just trying to produce the greenest types of soils and things like that they can for, specifically for that industry. But I imagine that will trickle into other industries as well. And I think it's kind of a purity thing, right? So even though it's a selling point in that your product is more green or quote unquote green, it's also, I guess, more healthy. I guess I don't know what the play is, but I think that it's an interesting thing.
I mean, I can't talk about the additional benefits out there. I know that there's lots of discussions going on in different industries that a few years ago weren't being had, where green hydrogen can play a role. And actually that's really good, because a few years ago it was possible to track everything that was going on there. Now there's so many different discussions being had. It's come to that stage where it actually becomes quite difficult to keep an eye on everything, which is nice, because if some of those fail, it means there's still enough market there to kind of push it over the line in the next few years.
Yeah, no, I think it makes a lot of sense. Outside of agriculture and transportation, though, what are maybe some other, I don't know if they're emerging markets or markets that exist already, where hydrogen could play a serious role either now or maybe in the future that people should be looking out for? Like, what are these, emerging technologies that people could watch for?
Well, one of the biggest contributions to global emissions is construction. So basically, steel and cement. So steel uses a lot of coking fuel in its production, and that just kicks out massive amounts of CO2. And people can say, well, we don't like CO2. We'll say, well, you do like steel, though. You like living in these homes. And it's the same with cement, right? Until now, there's not been a really good way of offsetting those those emissions. Hydrogen can be used as a reducing agent in steel production, and there's a couple of projects underway or about to start. The ones I know of in Norway and in Italy. So replacing carbon-based fuels with hydrogen for the reducing agent there, trying to bring the cost down for that. And suddenly, if you can create a market for your green steel, if you will, that creates a huge demand for green hydrogen. So the demand we have today will increase, 50-fold almost overnight. It will push up the cost of steel unless your hydrogen is cheap. But that means that we really have to focus on the cost reduction that we talked about before with renewables at scale. And that's happening now. Same in cement. You can use hydrogen to reduce your CO2 emissions from the cement industry. And I think we will see probably certain states in the US, like California, bringing in regulations for kind of state-funded builds where they're going to be total CO2 allowances for buildings, which means that really low carbon steel, low carbon cement is going to have to start playing a role. So hydrogen will fit in there. So it's really interesting space to be involved in. Right now, we're not producing a lot of steel or cement using hydrogen. And I can't guarantee we will in 5 years, but beyond that, I think the numbers will look pretty significant.
So I think it's interesting to look at those sort of upstream side effects or the upstream effects and how they can trickle down, just down to the concrete. But by making these changes further upstream, you can make some real impacts. And I think it's one of the jokes that I always crack is, about like a Tesla or a Prius or whatever. I think the big joke was around the Prius in that it took more fossil fuels to produce it than it will ever save. And so it's these kinds of, jokes where they're not thinking about all those downstream consequences. So yes, you've built a great electric car and it saves me, the consumer, some money, and maybe it's not producing as much CO2 now, but, all the fuels and oils and chemicals and things you burn to create this product, sort of offset. And so I think it's good to be thinking about those little higher up the chain things.
I was going to say, you mentioned California, and I saw in the news just recently that they're starting to trade water on the commodities market in California right now, just because the lack of it and the agriculture industry that is in California. Can hydrogen be produced through saltwater or seawater? And would that have an effect as far as how would that apply into maybe creating, because the exhaust and the emissions from a hydrogen setup is water. Would that put more into the environment and create more of if every car was running on hydrogen, would it put more water into the environment?
Well, that's a really good question. I did some calculations a couple of years ago on that. So hydrogen fuel cell vehicles are more efficient than regular vehicles, but if you burn your diesel or your gasoline, what's coming out the back, even if you burn it perfectly, is CO2 and water. So your diesel, your gasoline produces water anyway.
Okay.
Because it's inefficient, you produce quite a lot of it out the back. So the difference in a hydrogen fuel cell vehicle is there's no CO2 coming out and it's just water. A refinery uses a lot of water anyway. So when you're producing your diesel or your aviation fuel, there's water involved there. When you're drilling for oil, you're using a lot of water as well. And I know the industry will say that they're very good at reducing that amount, but it's still used. So there are upsides for hydrogen that you don't necessarily need some of that water to begin with. And you can produce hydrogen with salt water electrolysis. It's not the easiest thing to do, but there are some really interesting research groups out there and some teams focusing on, look, we have areas where we don't have all this really huge amounts of very pure water. Can we produce it using, salty water or briny water? It might cost a little bit more, but because the cost of water over in our area is so high to begin with, that the end cost for your hydrogen is pretty much the same. So there is potential being to that.
That's very interesting. I'm so excited to see this technology take off. I just want to jump ahead 10 years and see what's going on. With that said, I follow a group on Reddit called the Hydrogen Societies page. And in their introduction, they say that hydrogen is $1 trillion industry being born in front of our eyes. With that said, how can someone like Ryan and I get involved in maybe investing into this industry? Is there consumer level investment platforms where we could be a part of it and maybe profit off of it in the process?
There are some very good smaller companies out there which are listed on the various stock exchanges. I don't think I should list which companies I'm thinking of. I may have some shares myself, so to speak.
Okay.
Yeah, there are some ones listed out there. There are some companies which have a lot of hype and have gained a lot of big name investors and are making a lot of promises. And the way I view it is, if the promises are glamorous and if they say they can do everything, I keep far away from, because they can't do everything, right? Even there's just so much difficulty still left in doing one thing perfectly. To say you'll do everything is a problem. If they say, look, we have partnered with X, Y, and Z, and X, Y, and Z all have these competencies, and together we're going to form a consortium and do something, that's fantastic. That's that's kind of investment grade in my book. If they're just kind of plowing away for several years, if the technology has been spun out of a good university or research institute, if their CEO has a relatively technical background, then they're the kind of things that I look for in an investment. And there's still a lot of small companies out there which haven't really reached kind of early financing stage yet. So there's some of the small companies I'm working with, speaking to the venture capitalists and some big businesses to say, there's a gem here. They've not advertised themselves well in the past, but you need to be taking a look at that. So maybe there needs to be a better platform out there where the likes of kind of early stage retail investors can help these companies without having to go down the VC route. But that's still pretty much an open area pre-IPO.
Yeah. So I wonder too, just kind of as an extension of that, I mean, so much about getting a new technology sort of put in place is sort of consumer adoption. Like, what do you think are the sort of the barriers? I mean, is it an education thing? Is it a marketing thing? Like, I mean, how can we get this kind of information in front of the people who actually end up, voting with their dollars for this kind of stuff?
Yeah. For most consumer things, people don't want to care about the issues with it. Like behind the scenes, most people don't know really how an internal combustion engine really works. You fill it up and it goes. So we need to make hydrogen just almost kind of boring in its simplicity. Throughout the years, people have been trying to say, look, hydrogen is safe. We've overcome all these problems, blah, blah, blah. But as soon as you say something is safe, people are like, why are you telling me it's safe? At this point, it is. We really need to almost make it kind of mundane. Get hydrogen buses on the road, then people find out that the bus they've been driving around is a hydrogen bus. If Toyota and Hyundai and Nikola and Volvo produce these big Class 8 trucks that are on the roads every day running on hydrogen, then if they can run on hydrogen, your F-150 or your Camry or your car easily can. So it's just getting it kind of visible. Don't brand everything with this is hydrogen. It makes it a bit too special. Just get things out there. Have companies adopt.
It's funny. I will absolutely butcher this, but so for people who didn't hear the big news the other day was that Jeff Bezos stepped down from Amazon as their CEO. But just to tie it to exactly what you're saying, he said that one of the big things, or I guess the biggest compliment to an inventor, so in his mind, he was talking about Amazon and all the things they've revolutionized. But in the case of hydrogen, is just what you're saying, is that when it becomes normal, when people sort of yawn through it, you finally made it. Like, it's not until that people are bored with it that the actual payoff of your innovation is there.
Exactly. Over in Europe now, I mean, there's just wind turbines everywhere. And originally people were like conspiracy theories about wind turbines and blah, blah. Now you drive past them, you don't notice them. So I want to be able to drive past a hydrogen refueling station and it's nothing special. It's just there.
So what do
Very
you
cool.
see?
Well, hey, as we're getting to the end here.
Ryan,
oh, sorry. Go ahead, Mike.
Sorry.
Sorry. Go ahead.
What do you see happening with existing infrastructures and cars that are out now? Do you just see them, in 10, 15 years, they're just going to the junkyard and recycled into creating new hydrogen vehicles? Or, because as a consumer, I just bought a new car, a new diesel, a Volkswagen, and I'm still making payments on it. And I don't see me buying another car that's a combustion engine. I see, like, if I was going to go and buy a new car right now, I'd probably buy a Tesla, under the impression that maybe there'd be a conversion kit for hydrogen on a Tesla vehicle in 5 years. Do you see something like that coming into place?
Yeah. So in the UK over here, new diesel and petrol cars are not allowed to be sold from 2030. From 2035, no hybrids can be sold, which means basically for cars, battery, electric, and hydrogen. As the number of those cars start going down the road, your petrol and diesel cars, the profitability of your fueling stations goes down, so they start to close, which means that it's harder and harder to refuel there. So people get more frustrated, and it pushes up adoption of electrified vehicles. The government almost certainly will do a buyback scheme at some point. So trade in your old car, get X thousand pounds or dollars towards a new zero emission car. And of course, there'll be some people hanging on who have a very nice car that they want to keep on the road. I see eventually that ending up like leaded petrol. You have a classic car where you buy special leaded petrol that you can't get at your Shell or your BP garage. You have to buy that separately. So in the future, you'll be buying your diesel from specialist providers and recharging your cars at your local Kroger or Meijer or wherever, or refueling your hydrogen cars potentially at your Shell stations or other operators.
I was wondering about that. That actually makes a lot of sense, because as the supply of gas and natural, fuel that's out there goes down, people are going to just, I honestly think in 10, 15 years, it's going to change completely. And I hope so. I hope that more countries will take on legislation like what you guys are doing and kind of force the issue, because the tipping point where if we don't address it, it's going to be a problem here in the next little bit. So
absolutely. I'll be happy to come back on 10 years and we can see if the predictions are true.
Yeah.
Very good. Well, hey, as we're starting to wrap up here, do you mind just giving people a little bit of data where they can track you down online if they want to get in touch, or if they'd like to learn more about hydrogen or the work you're doing?
Fantastic. Absolutely. I'm always happy to have a chat with anyone about hydrogen. If they have consulting needs, come and speak to me, or if you just want to learn a little bit more. The website for the consulting company is rhcimzadi.com, and you can find me on LinkedIn, Andrew Murphy. I usually come up if you type in Andrew Murphy hydrogen at the top or near the top. Always happy to have a conversation.
Yeah, well, thank you so much for making time for us.
Andrew. This has been an amazing chat. Yep. So, and thanks to everybody who tuned in this week and every week, and we'll see you all next time.
Okay.
Cool. Just like that.
Oh, he left.
Oh, and he bounced. Damn it. I wanted his stock picks.
Hit him up on LinkedIn.